and welcome to the AI on Demand webinar series, AI Innovation from Research to Market. My name is Loredana Bucteneanu, and I'm a member of the AI on Demand team, and I'm happy to be your host for today's session. For those who are new, AI on Demand is a community-driven platform that is designed to empower the European research and innovation ecosystem by providing a series of resources such as data and AI experimentation tools, AI assets and data, but also training and learning resources, information about events, funding opportunities, and so on. So as part of the objective of AI on Demand, this webinar series aims to showcase AI innovations that are developed in the research environment, but that which demonstrate real-world application. So the series aims to bring together research and industry, highlighting AI tools and services that can support businesses and developers to advance their own AI-driven solutions. So today's session is focused on how AI-driven innovations are tackling resource management challenges and promote sustainability across key industries. So from precision agriculture to smart manufacturing and advanced recycling solutions, our speakers will share today insights from cutting-edge projects that are transforming the way we use and manage resources. So I'm happy to present the experts that will guide us through today's discussions, namely Andrea Borghesi, Assistant Professor at University of Bologna, who will present the AI for Europe benchmarking guide, Gian Pietro Bontempi, R&D Manager at Fonderia di Torbole, who will present the results and resources of the Alchimia project, Erato Lazarou, Project Manager and Research Associate at the Smart Farming Technology Group at the Agricultural University of Athens. She will present the lessons learned from the pilots of the Smart Droplets project. And Freddy Raptopoulos, a robotics engineer at Robenso. He will present the real-world deployment of a portable robotic material recovery facility in Kefalonia, developed by the Reclaim project. So I will give first the floor to Andrea, who will present the AI for Europe benchmarking strategy, which in the context of the European Green Deal is a vital tool in promoting environmental sustainability. So Andrea, the floor is yours.
Thank you. Thank you a lot, Loredana. Thank you, everybody, for your participation. I'm going to share my screen now, so you will be able to see my presentation. Okay, as Loredana was saying, I'm an assistant professor at the University of Bologna, tenure track, so with some hope I will become associate professor in a few months. And I've been part of the AI.
No, I think we just lost him there. Maybe we'll give him another second to hopefully get back online. You can still see his presentation, but I
platform we wanted to help also do benchmarking. And why benchmarking, especially, are you saying something?
Andrea?
Okay.
We lost you for a second. So if you
Can you hear me?
Yes, now we can hear you, but we lost the first part of your presentation.
Oh, I'm very sorry. I am I'm at university, so the Wi-Fi is up and working, but sorry for that. So I will do again my quick brief introduction. Sorry everybody. And Loredana, feel free to stop me as soon as you notice that you lost me again. I wanted to tell you, everybody, that I've been part of the AI for Europe project since its beginning. So I've been very happy to collaborate with all the people involved. And today I'd like to talk to you about a transversal and orthogonal service to the application that Loredana was mentioning earlier. In particular, within the AI on Demand platform, we wanted to include a tool and more precisely a set of guidelines to help people perform benchmarking. I will describe later what I mean with benchmarking and why it's relevant to AI application. I just wanted to tell you that it's part of it's part of the current version of the AI on demand website and platform that can be easily reached. There is going to be the link in a couple of slides later than this, and I want to try to make you understand why performing benchmark in a rigorous and systematic manner is actually very important. It's important in several aspects of IT and computation in general, but in the case of artificial intelligence application, in my perspective, is especially important. So, why benchmarking? Well, nowadays, algorithm developers have to answer a variety of different questions when they decide to go from a prototype to the actual deployment of an algorithm. So, for example, given a certain AI algorithm, they have to respect a series of constraints, which might be on the time requirement of the algorithm. My algorithm need to run within a certain time frame. I have a certain budget, which might be monetary budget, but might be also any other kind of budget. I want to reach some, let's say, minimum threshold in terms of solution quality, and so on. And to, let's say, finalize the deployment of an AI application or AI algorithm more in general, the developer should decide which is the most optimal hardware architect, hardware resource to run my algorithm on top of which. Conversely, and in a, how can I say, specular manner, if instead, as an AI algorithm developer, I am given a set of hardware resources and again, a series of constraints, I might be tempted to ask the question, what is the best algorithm for my specific task? Let's assume a task of image classification, okay? There are several thousands of different models, AI-based models for performing image classification. And they have different characteristics. They run on different type of data, but even given the same type of data, given the same, let's say, pipeline, they might have different behavior according to different hardware on top of which they are run. So answering this question, what is the best algorithm selection, is not straightforward. It's a very complicated question. This is where benchmarks come into play, and this is why benchmarks are actually important. So to help people perform benchmark in a rigorous manner and in a systematic manner that is also conformal to how the industry standards go, so how industries and research practice perform benchmarking nowadays, we decided inside the AI for Europe consortium to build a series of guidelines. So basically, we prepared a benchmarking guide. Okay, you can see here there is a link to it, and basically it's a very detailed step-by-step guide on how to perform benchmark in a trustworthy manner, accountable manner, transparent, and fair manner. And we also stress out that the outcome of this benchmarking activity should be comparison between different models on one hand, between different AI models, and on the other hand, a series of, let's say, rules or guides or, let's say, hands-on practical suggestion in order to select the optimal algorithm given a certain task and to select the optimal hardware given a certain task and given a certain model. So basically now what I'm going to discuss is a series of slides that encapsulate what is present in the benchmarking guide, because just showing the benchmarking guide is not really very easy to focus and not very clear to see as a series or as a presentation. But what you are going to see now is all included into this website here, at this page here inside the AI for Europe benchmarking guide, inside the AI demand platform, sorry. So why benchmarking is important? Well, it's probably the only way to guarantee reproducible results. So in order to have a comparison between different models, it's fundamental to have benchmark and to have baselines. So people can try to replicate this baseline and then can try to beat them, or at least can try to understand if their current performance is on par or not with the state of the art. Also, objectivity. Benchmarking is important because if done correctly, so that is in a rigorous manner and in a transparent manner, is the only way to actually measure the objectivity, the quality of the results produced by our algorithm. Also, benchmarking is important because it allows accountability. It's the only way that we can actually, let's say, make sure that the claim made by a group of researcher or industry or academia is actually corresponding to what the data represents, with what the data portrays. Also, benchmarking goes into the direction of providing the support to the regulation that is so crucial, especially in the European environment, because in the European Union there is a strong sense towards, especially in the AI Act, I'm thinking towards accountability and transparency. So there is the need of demonstrating what you are claiming, and there is the need of actually providing proof of what you are claiming about your models and your algorithm. And in this case, fulfilling documentation is fundamental. It's fundamental, and the best way to do it, in our opinion, is to provide solid benchmarks. Just to clarify to people that might not be familiar with it, what is a benchmark? Basically, a benchmark is the combination of running, executing, evaluating an AI model or an AI algorithm on a given hardware platform, plus standardization. Standardization to make this run, to make this execution compatible and comparable with other run made by other people or made at different point in time. So basically, there are three key steps in starting a benchmark. We need first to decide which are the tasks that we are going to try to build a benchmark on. For example, image classification, object detection, language translation. Then we need to decide which are the dataset that we are going to run our benchmark on. So we have our algorithm, we have our model, we need to decide on which data we want to evaluate our model. Okay, and choosing the data is very important because the data might contain various assumptions, might contain correlation, might contain distribution that are not actually representative. It's important to explicitly state which data we are working with. Then we need to, and it is a very fundamental point, define the metrics that we will use to quantify the performance. Because if you are going to run an experiment, we need to say we plan to measure X, Y, and Z. And we need to possibly using standard metrics. If not standard metrics, we need to justify why we're using those metrics. So the benchmark, theoretically, as an aspiration, should be repeatable. Given the same condition, the same result should be obtained, should be comparable across different models and systems, and should be meaningful. We should decide, for example, to employ metrics that are connected in a meaningful manner with the task we are trying to solve. If we are performing a task of image classification, there is not a lot of sense in using mean squared error as a measure, which is instead a typical measure used in regression task and forecasting task. Okay, so these are all aspects that needs to be taken in account since the beginning. So I want to give you a bit more, let's say, overview of what are the more typical and more standard metrics for benchmarking. I'm not going to read them all because it's pretty boring, but just to give you an idea that there are different classes of benchmarking metrics. And I want to stress out that good practice is not just to focus on a single metric. In fact, it is strongly recommended, and we'll get back to it, to consider and record for a given algorithm run multiple metrics, because it allows to fulfill, let's say, different needs at the same time if we record multiple metrics at the same time. We have performance metric, and the performance metric are strongly dependent on the task at hand. For classification task, classical metrics are accuracy, precision, recall, F1 score, much better than accuracy. For regression, any kind of error, first order, second order, R squared, a bit more reliable, the R squared coefficient. We have then different metrics for specifically language tasks, so NLP, such as perplexity. Then for computer vision, we have the mean average percentage error, and then we have also the intersection over union boundary for object detection. Then we have a series of transversal metrics that are not depending on the task, but they try to capture the efficiency of the algorithm itself, such as, for example, the latency, the time for prediction, the time to compute inference in a machine learning model, how long does it take to process a batch of data. Throughput is very similar. Model size instead try to capture statically the memory footprint and the storage footprint of a machine learning model of an AI algorithm. Usually we can divide, we can also consider that, for example, average memory consumption rather than peak memory consumption. How long does it take to load the model? Inference cost can also be computed in terms of how much am I occupying the GPU, so CPU and the graphical processing units GPU usage, and so on. So these metrics are required to characterize the behavior of a given algorithm, and they are typically tied to a specific hardware. So the latency, for example, strongly depends on the type of hardware we are using for running our benchmark. Model size instead is less dependent on the hardware itself. So these are kind of a mixed bunch. Then we have a series of, usually I would say, less explored metrics. So these are kind of 4 block of metrics that are, for me, as a researcher at least, very, very relevant. And I think they will become even more relevant in the future, but I'm going to be a bit light here. But just to give you an idea, especially towards trustworthiness, which is one of the crucial aspects of artificial intelligence nowadays, robustness metrics are very, very important. So understanding how our models are sensitive to input noise or adversarial example, or how good they generalize over auto-distribution data. This is very important to record. These values are very important to be recorded because they really tell you how much your model is robust. Similarly, fairness is very important because we noticed in the last few years that AI models can enhance discrimination with enhance, maybe it's worsen discrimination, sorry, because they can make biased decision according to biased data. So it's very important to measure the performance of the models across different subgroups, and especially if there are minority groups. So fairness metrics are becoming more and more important. Similarly to sustainability metrics. Everyone knows AI, great, fantastic, but it consumes a lot of energy. So metrics such as the energy consumption of the inference done on an AI model or the carbon footprint are becoming more and more important. Honestly, sustainability metrics are still not so widespread in the benchmarking world. Most of the benchmark I am usually, let's say, having experience with are not covering sustainability. So this is something that really needs to change. Finally, to make models more usable, usability and interpretability are also aspects that should be clearly taken into consideration while executing a benchmark. Having said that, what is the shape of the output of a benchmark? What the benchmarking output should be? Well, we need to have at least the raw results because we need to report the scores obtained by the algorithm for the different metrics because they encapsulate the behavior of the algorithm for a given task goal. Contextually, it's very, very important to store metadata containing information about the configuration on which the algorithm was run, so the so-called hyperparameters of the model, because the hyperparameters specify the context on how the algorithm was tuned and how the algorithm was actually executed. Then we need to specify the hardware configuration, what kind of hardware has been used, the software configuration. What is the operating system that have been used? Was it Dockerized? Was it virtualized? What were the runtime settings? Are there any GPU clock limiter or any kind of aspect that can impact the benchmarking results? Also, the metadata should specify model version, random seed for replicability, and of course, the data and possibly the different data sets used to obtain the benchmark. Finally, but slightly less, let's say, fundamental than the raw results and the contextual metadata are logs and traces, because they enable better reproducibility and explainability. Typically, logs and traces are harder to store due to storage limitation. In an ideal world, it would be great to have logs because they allow to actually track at the maximum level of trust possible the progress of the benchmark during its execution. It's important that output are structured, so they follow standard format. Typically, in this sense, JSON or YAML are fine. CSV file are also okay. JSON is probably the standard bearer for this. Version, so the data set and the model version should be clearly documented and explicitly documented, and interpretable, but interpretable in a very broad sense. In this case, we simply want to highlight that if you perform a benchmark, you clearly need to connect it to the desired objective, to the stated objective, and to the tasks you are trying to solve. We have a little example of benchmarking output in our guide. This is taken directly from the guide. You see, this is a possible output in the form of a tabular data. In this case, we have a series of hyperparameters that specify the machine where the algorithm was run and the parameter that configure the algorithm and the model execution, and we have a series of possible metrics. Okay, this is very generic, very high level, because the guide doesn't want to, at least in this page, we don't want to give you practical example. We are trying to formalize the process of benchmarking a bit more. Okay, another important thing are what type of benchmark can we run. We can proceed at component level. For example, we want to compare different classification models on the same data, or we can focus on more broader pipelines. And in that case, we are talking about application level benchmarking. We can perform synthetic benchmark and real-world benchmark. Synthetic benchmark are usually done on synthetic data, easy to change, easy to scale and modify, good for doing a preliminary model selection to get an idea if a model is promising or not. They might not represent the complexity of the real world. So synthetic benchmark might have the drawback of not generalizing so great. Real-world benchmark that is run on real-world data are very practical, they have a very high practical relevance because they are much closer to actual feasibility in terms of deployment. They tend to be better transferable. The results that you obtain on a real-world data set, in a benchmark on a real-world data set, is going to tell you much more convincingly how your application will fare in real-world application. Harder to control for biases noise because it's always very messy. Real-world data is always very messy, so it needs to be taken with a grain of salt, the results of on that. As a main important things to remember, think first on the goal that you have in mind and choose your benchmark. For example, for model selection, synthetic benchmark are okay. For deployment evaluation or robustness testing, I strongly recommend to employ also a real-world data set and a real-world benchmark if possible. Typically, the best approach is maybe to start with some synthetic data to obtain some first result and get a feeling, and then move towards the usage of real-world data to further validate the results. A bit technical, but very important. It's important to have common programming interface and standard programming interface for benchmark, so APIs in a standardized manner, because they allow for clarify easily the input of the benchmarking process, and they make the benchmark themselves more modular and reusable, and also having a standard in API allow for greater transparency. This is important, especially for people that are operating on a, let's say, programmatic way, and they try to run multiple benchmarks on the same time. So having good API is important because it allows for a better integration with existing automated pipeline, and they tend to, let's say, also provide a better level of accountability, because if you employ clear and transparent and explicit APIs, it generally means that you had to think first about the schema definition and so on. And having a clear defined schema help in actually let the benchmark be more interpretable for human user. Then, automation in benchmark. Why automation in benchmark? Well, automation in benchmark is important. So we strive and we advise for having automatized process as much as possible, because they tend to reduce human error, and they tend to simplify tend to streamline the process of getting to the outcome, the output of a benchmarking process. The key part, the key aspect that automated process should take care for is first the environmental setup, and for this, typically having a partially virtualized environment such as Docker or Conda is the key, because it allows for more replicability of the benchmark itself. The automated tools should run end-to-end, so they should start from feeding the data to the model, and then deploy the model and log the log the metrics collected during the run. Automation tools should also allow to track the version of the code, the version of the models, parameters such as starting point of your application, in random initialization number, and the data itself, and finally should produce a reproducible and shareable report. And for this, there is a variety of tools that can be already considered, and in general, it is better to choose something that is compatible with some, let's say, pipeline already well established, such as classic is GitHub Action. Okay, this I'm going to be very quick in terms of the process. What we need to consider, we need to consider especially reproducibility. I would say is the most important consideration, plus versioning control, because it's the only way that we can actually explicitly track the let's say, comparability of our benchmark with previous benchmark. We need to also test our models as much as possible in realistic settings, and it's always important to take into account the hardware we are using our model, the hardware resources that we are actually deploying our system, and if this cannot be controlled. For example, we cannot run a large machine language, LLM on the amount, all the computing resources we want, because it's very costly, very expensive. It's important in a benchmarking run to actually state it and keep track in a clear and transparent manner of the hardware that has been used. What are the open challenges in benchmarking so far that we try to help people focus on while doing a new benchmark? Well, there is in general a lack of standard, and this is true. Standards are growing, are becoming slowly adopted, but especially in AI, which is a very expanding sector, everyone is proposing his own standard. So standards are still lacking. It's also hard to make sense of the results that can be obtained by benchmarking different algorithms, because they tend to be extremely depending on the hardware underneath. So this is why, for a fair comparison, it's very, very important to state clearly and explicitly the hardware that have been used for a certain benchmark. It's also an aspect of ambiguity in terms of which metrics are the most relevant for a given task. In general, there are trade-offs. In general, for example, if you consider fairness metrics, it's well known that if you have a classification task, if you want the model to be more fair, in general, the accuracy of the classifier will be lower. So never to trust a single metric. This is why I strongly suggest to always record multiple metrics when executing a benchmark, because it's important to provide a wide and holistic picture. Finally, it's also important to take into account if the quality of the data. Quality of the data is another can of worms that I'm not going to open now, but it's very important. It might invalidate benchmark outcome because there might be bias in the data set, might be not representative of other population. they might say there must be some very big sampling bias. How do we solve it in benchmarking? We don't solve it in benchmarking, but we at least pretend that people are transparent in the data that they use, in the split that they use. So at least future researcher and practitioner can actually try to replicate what is being claimed as effectively working. There are multiple opportunities to improve, shared benchmark and open leaderboards. I'm very fond of going beyond mere accuracy and performance metrics. I strongly believe that robustness and energy and sustainability needs to be taken into account. And in general, these are, let's say, motivation towards using more findable, accessible, interpretable, and reusable tools. So we want to respect FAIR principles, but I'm going to be pretty quick on that part. In our guidelines, we also provide on the AI on demand platform, we also want people, let's say, to help people meeting the desire of the fantasy AI developer described before. So the idea of how do I choose the right algorithm for a given task, and how do I choose the right hardware for a given task and a given model. And it is possible to build automated pipelines and automated matching of AI asset given a certain constraints, given a certain, let's say, series of machine learning model that can try to learn the behavior of an algorithm. It's all based on automated, clear, transparent, and explicit benchmarking. So this can be found you can go deeper if you are interested in our web page, in our guidelines. And finally, I want to just conclude by saying that benchmarking is fundamental. It's fundamental, and we can also say is foundational, because it's the only way we can actually build trustworthy, efficient, and transparent AI, which are crucial for the development and the adoption of the AI in the future. In our AI for Hero project, we try to create this service that is more like a series of guidelines. We want to help people understand how to build a benchmark if they have to start from scratch, how to be rigorous in the creation of the benchmark. And we also give some practical tips to programmers in how to try to integrate their benchmark pipeline in standard repository that maybe you have heard, such as OpenML, Hugging Face, MLFperf, and so on. And basically, we believe it's the only way to provide a holistic evaluation of and fair evaluation and comparable evaluation of AI models and algorithms. Having said that, I think I concluded. So thank you all for your attention. I don't remember, Loredana, is there a session for question now, later? We simply have the presentation now.
Yes, we will do a questions and answers session at the end of the presentation.
Okay.
So I invite the participants to write in the chat if they have questions for you or for the other speakers, and we will take them at the end of the presentations. So thank you so much, Andrea, for the presentation of the benchmarking guide. It's a tool that can be used by anyone and across the board to evaluate AI algorithms. So now I would like us to go to more applicable, let's say, AI driven solutions linked to our theme today, the energy and resource efficiency. So I would like now to invite Gian Pietro to share about their experience with using the Alchimia platform in their factory. Gian Pietro?
Yes, thank you, Loredana. I share my screen now. Okay, you see my screen?
We see it, yes.
Okay, perfect. Okay, before to start with the description of Alchimia, only a few information about Fonderie Torbole. Okay, Fonderie Torbole is one of the most important foundry of cast iron for produce brake disc and brake drums for automotive sector. The production is 100% gray cast iron, and our capacity is around 150,000 ton years. and we produce around 30 million casting part and 7.5 million of machined and coating. The turnover is around 150 million, and where our staff is around 500 people. We're located in the north of Italy, and our main customer is Volkswagen Group, Stellantis, Toyota, and Kia Hyundai. This is our product. This means ventilated solid disc brake drums, and mainly for passenger car, only 90% for commercial vehicles, and the supply is 30% casting and 65% machined part, and are 70% solid disc, 18 vented disc, and 12% the production of brake drums. For Fonderie Torbole, environmental and sustainability problem is a key point, and regarding circularity economy, the 90% of the material is recycled raw material, and the 95% of waste is recycling. Regarding sustainability, we produce green energy, the 25%, and we have inside in our company organic ranking cycle in order to reuse our heat to generate energy. In addition, regarding decarbonization, we have already defined a roadmap in order to arrive in 2030 for fully decarbonization. Okay, regarding Alchemia project, okay, before to start with Alchemia, it's better to understand our process and our problem. And for this reason, we have introduced Alchemia in this company. Okay, this is our process, our casting process flow chart. We start with the cupola, is a big oven that produces cast iron, 30 tons each year. After that, the liquid cast iron arrive into two holders, with one of 20 tons and one of 80 tons. After that, the cast iron can arrive directly in the pouring furnace or arrive in two induction furnace in case it's necessary to add ferroalloys or to increase the percentage of carbon inside the cast iron. After the pouring, the part is cooled, remain inside the sand for 40 minutes, and after the part remain on the metallic conveyor in order to cool down the part up to 200 degrees. But this phase is around, the time is around 3 hours. Okay, the problem that after 3 hours, we have the possibility to check the quality of the part. This means, okay, we have all the chemical and thermal analysis in this phase during the production phase, but we don't know if the final part, this means after 3 hours, the parts are okay or not, because we have no forecasting model to evaluate from the initial data, if the parts are okay or not. And our normal problem are the porosity on the part, the mechanical resistance, and the natural frequency. If at the end of 3 hours the parts are not comply with the customer specification, this means we have to scrap 3 hours of our production. This means a lot of tons of material. We lose a lot of capacity of our plant, and a loss of efficiency, loss of energy, increase of cost, and so on. For this reason, Alchemia platform will be used to perform it, to forecasting the final result. Okay, this means Alchemia solution predict the final result starting only the input data. Now we have ex post evaluation, but with Alchemia, we have the possibility to have ex ante evaluation. This means start before 3 hours, and we have the possibility to change our production or modify the chemical composition in order to reach the right chemical composition for have a good part at the end of our process. In addition, Alchemia is also providing information related to environmental impact. And in addition, thanks to federated learning, it's possible to have a scalability of this platform for other foundry. For example, we have in our group another foundry, and we have the possibility to scalability this platform for other foundry. Okay. At the beginning of the process, the first step of this project is to collect all our data. This means we collect input data coming from production data. This means chemical analysis, thermal analysis, the temperature, the inoculation time, production time, all information at the beginning of our process. But at the same time, information about the quality of our part. This means if in our part there are problems of porosity, mechanical resistance, frequency, we have correlate all this data, and with this data, our partner prepared a model in order to evaluate at the end, in the second step, the result starting only the input data. This means ex ante evaluation. This means in the second step, we have connected all our data in automatic way in order to have the possibility to share our input data to the model. This means elaborate the Alchemia platform, elaborate this information, and thanks to artificial intelligence system, have information if with this data, the final result will be good or no good. In case of no good result at the end of our process, the operator immediately can have the possibility to modify the production and adjust our process in order to have the good result at the end of our process. Today, after the implementation in our system, all the hardware and software to manage this platform is in evaluation phase. This is very important because now it is necessary to evaluate the robustness of this platform, and in case it's possible to have an iterative process in order to optimize the process and change the model in order to have a good result in the last phase of the process. Okay, conclusion. Okay, today our system is not able to predict the final result. Alchemia system with the your base, this means with machine learning base, with federated learning, have the possibility to evaluate our starting process and minimize the scrap of our material. And if we reduce the scrap, we have a lot of benefit at the end of our process, because if we reduce the scrap, this means reduce of energy, we have a reduce of CO2 emission, we increase our capacity because we have no scrap, and this means we have save money and to be more competitive in the market, because now in the automotive sector, the key point is the competitivity. And with this platform, the result is to increase our competitivity in the market, in the automotive market. Okay, I think that's all. If you have some questions.
Thank you so much, Gianpietro. So my understanding is that you will have more results in a few months' time, right? You will
Yes,
evaluate the efficiency of the Alchemia platform.
yes, it's necessary to evaluate. It's necessary month in order to evaluate this system, and it's not possible only in a few weeks, but it's necessary 3-4 months, and there is the possibility to optimize in different phase this platform.
Okay, great. We will keep an eye on it, and we will be looking forward to hear about the final results. Thank you so much. Then I would like to go to another application of AI-driven solutions. So I will give the floor to Erato that will share some key insights that were gained from the Smart Droplets project.
Yes, sure. Can you see my screen?
Yes.
Yes, can you see it in a presentation mode?
Yes, we see it in presentation mode.
Perfect. So thank you very much and welcome everyone. Today I will introduce you the Smart Droplets project. It's a European funded project that brings together AI, robotics, and data-driven solutions to revolutionize how we manage pesticides and fertilizers in agriculture. The Smart Droplets mission aligns directly with the European Green Deal sustainability goals. The Smart Droplets is a 42-month project that started in September 2022, so we have almost 1 year ongoing. Our vision is to transform the crop spraying using smart systems. Think about the AI models, digital twins, and autonomous tractors working all together to improve sustainability while ensuring at the same time the high quality food production. The Smart Droplets directly supports the 2030 European goals, for example, the 50% reduction in pesticides, 50% reduction in nutrient losses, and 25% of land being farmed organically. Our technologies are designed to meet these targets, so these are also KPIs from this project. At the same time, we are trying to address major agricultural challenges from chemical overuse and robotic system safety to social acceptance and education. The first one is the rapid changes in the agricultural environment. As you know, the agricultural areas are characterized by continuous changes due to the variable nature of soil, light, and weather conditions. Also, the excessive use of chemicals. The common practice involves the excessive use of pesticides and fertilizers that cause significant environmental impact with very important consequences for soil, water, and atmosphere. There is also the need for a resource optimization, the necessity of improving the efficiency of chemical applications, aiming to reduce waste and enhance environmental resilience. The European Green Deal goals for sure, the need to comply with these goals and for reducing the pesticides used by 50% and reduce again the fertilizer used by 20% by the year of 2030. The integrated approach, the lack of an integrated approach goes to the innovation in spraying, the need for more selective methods of pesticide application that will improve quality and efficiency. And at the same time, they will reduce the dependence on chemical products, the resistance to diseases and pests, and for sure the safety and efficiency of robotic systems, the development of safe and efficient robotic systems that can operate autonomously under the challenging conditions of agricultural environments, and also the utilization of data and artificial intelligence, And last but not least, the education and social acceptance, enhancing the understanding and acceptance of these innovative technologies by farmers and the broader society through the appropriate education and training. This project brings together 9 partners across the Europe, universities, research institutions, companies, and industry. But what we are trying to create, we are developing an integrated smart spraying system. This includes robotics, AI, data management, and digital twins. The goal, what it is, to reduce the environmental impact and make field operations smarter and more efficient. That's why we have the pilots. And now about the digital twins, at the core of our system are the digital twins. There are virtual models of real fields. These allow us to simulate crop health, predict diseases, and optimize interventions before they happen. The digital twin is a core part of this project because it can use real-world data to model plant growth and predict diseases so we can avoid several things. Our vision system detects weeds and diseases in real time, enabling precision spraying. It validates and fine-tunes the digital twins recommendations, improving the system's accuracy and responsiveness. And now our robotic sprayers, sorry, can you see it? Yes, our robotic sprayers use a direct injection system that mixes chemicals on the fly. It stores up to 5 products and applies the right mix only where it's needed. So we can cut the pesticide use by 40%, nutrient use by 15%, and water use by 50%. The tractor operates autonomously using GPS and sensors to navigate. It detects where and how much to spray using optical recognition, reducing chemical at the same time and improving environmental safety. These vehicles operate independently using GPS and sensors to detect pests and weeds. And all these components work together as a complete solution. The AI, digital twins, retrofitted tractors, and intelligent spraying systems, this synergy maximizes the efficiency and minimizes the environmental impact. The aim is to support both environmental goals and real-world farm economics. Let's now look deeply at how these technologies perform outside the lab in actual field conditions across the Europe. In Spain, we tested the smart droplets on a 155-hectare apple orchard with a yield of 6,500 tons annually. The focus here was adapting our system to complex orchard topographies where uniform rows are disrupted by trees of varying size and shape. Here you can see how the system perceives its environment. On the top left is the real orchard, and the remaining views show how sensors can generate a depth map and 3D model of the rows. This enables precise navigation and targeted spraying, even in variable terrain. We benchmarked both visual and LiDAR based on SLAM algorithms. These localization systems ensure the robot can map its surroundings and plan routes in real time, even without a reliable GNSS signal. Here you can see an overview of our pilot. You can see the tractor without anyone in its cabin and the spraying system behind it. It's full autonomous, and you can see how it can turn left and go again to another row. Here it stops spraying. That's what we want in order to save the pesticides. And now it turns, and when it's on the middle of the row, it starts spraying again. Now Yes, as you can see, it starts again spraying. The second pilot is a wheat field in Lithuania. Here we tested the system in broad acre farming, focusing on coverage-based spraying. This site uses similar equipment, but optimized for flat, large fields rather than the orchard rows like Spain. Here you can see the video from this pilot. It's an open field, as you can see, because it's a wheat field, again with no one in the cabin. It's spraying. That's it for our pilots. We have built also an evaluation protocol in order to see the results and evaluate them at the end of the project. And we have also, beyond the technologies, our success depends on how well the farmers and technicians and agronomists, for sure, can understand and use this system. That's where our training and outreach efforts come in through the Smart Droplets Academy. The Smart Droplets Academy provides an annual training for non-expert stakeholders in agriculture, covering all these things. Through in-house and online sessions, webinars, and master classes, participants gained and will gain hands-on experience with real-world applications. The program also targets domain experts, highlighting the AI's benefits for productivity and health. All learning materials, including the kits, videos, and webinars, they are available at Smart Droplets Knowledge Base. And here you can see some screenshots from the Academy. That's all from my side. If you have any question, you can reach through the chat or through the email. Thank you very much.
Thank you very much, Erato. That was very interesting to see how you apply that this AI solution in agriculture. Do you see any application beyond agriculture as well?
There are some applications for sure, but still need the research and still we need to validate the results at the end of the project. So we can say that can go beyond the agriculture.
Okay, great. So we need to keep an eye on your project as well to see towards the end of the project what are the results. And finally, I would also like to give the floor to Freddie, who will tell us more about the pilot that the Reclaim project is doing in Kefalonia.
Hello, everyone, and thank you for joining. Let me share my screen. You can see my screen?
Yes.
Okay, so you can see my presentation too. So I'm Freddy Raptopoulos, and I am co-founder and technical lead at the company Robenso. In Robenso, we develop autonomous sorting robots to address the waste industry, and we have multiple robots installed in factories in Greece. As part of the Reclaim project consortium, we are also responsible for the robotic installation of the Reclaim project. And at the Reclaim project, we have developed a small-scale material recovery facility that is fully autonomous with robotic sorters and is also portable in order to be deployed on the edge of our country. The idea of the portable, you can see at the right image, the portable robotic material recovery facility deployed at the island of Kefalonia. Basically, it is a 14 meters container, transport container with all the recycle sorters and all the identification systems inside. And I will also describe you how it works. The idea of the project came, as very well stated by Mr. Komnenos at the project panel, came from the unique geographical characteristics of Greece and the many islands and many remote places that have mountains between, and it's very difficult to implement the recycling systems that are implemented in other countries. As a result, municipalities end up following bad practices with what they do with the recyclables. And one example of a bad practice is what was happening at Kefalonia until the portable robotic MRF went there. So what Kefalonia and many other municipalities of remote places in Greece do is gather their recyclables, let them rest at a place for 2 or 3 days, because you want all the dangerous items to have their time to act. So after 2 or 3 days, it's not dangerous anymore, and we can load those recyclables at a truck. Unfortunately, we cannot compress them, so we cannot use the weight capacity of the load of the truck, but we use the volume capacity of it. We can compact it because we aim to transport them at an MRF, and the MRF has to treat them uncompacted. So the truck is after loaded to a ferry. With a 2-hour journey, we are at the mainland of Greece, and then another 2 hours travel with the truck in order to go to the city of Agrinio and unload the recyclables to the local MRF. There we managed to recover about 60%, and because the municipality of the city does not want to landfill others' residue in their land, we load again the residue back to the truck, back to the ferry, and back to the point that the journey started, where it is landfilled at Kefalonia. So what we do with the Reclaim project is we have installed the portable robotic MRF at the place that the municipality gathers their recyclables. We feed those recyclables at the portable robotic MRF, and then we travel to recover 60 up to 80%. Residue that occurs from this recycle is landfilled right next to the PRMRF, and the recovered material can be compacted. And when we have 40 tons of 40 tons is the weight capacity of a truck. When we gather 40 tons, we have a truck loaded and sent to other factories that upcycle the recycling material to meet the market again. I will explain you how the hardware of the portable robotic MRF works. We have an elevating conveyor that feeds recyclables at the vibrating feeder. This is basically a surface that that can unload the recyclables with a constant rate on the conveyor belt, but also spread them along the conveyor belt width in order to have an even density of recyclables on the conveyor belt. Then we have the we have the RGB camera and the HSI camera, where we fuse those images in the AI classification system, and we manage to localize and categorize the recyclables. Then we send those commands to the three 1.5 degrees of freedom robots that is also our company responsibility, and I will explain you later why their name is so and what is the innovation of those robots. We use blowers, valves, and filters in order to bring the vacuum source at the end effector of the robots. Then we have a magnet in order to attract ferrous recyclables. And then we have another system with an RGB camera again and two 2.5 degrees of freedom robots, the controllers and the PLC in order to control the whole container. And we also have 12 different bins in order to sort the recyclables. The loop of the recycling sorters is we have a camera. The camera sends the image to the classification system. The classification system can produce the different masks with different classes. This information synced with an encoder that sends us the velocity of the conveyor speed are analyzed from the robotic sorter controller, and we can command the robot to pick and place the recyclables. With the use of a vacuum and a valve, we can physically suck the items and place them to the bin. Here we have the video of the inside of the container. Those are the first three 1.5 degrees of freedom robot. The name comes from they have the freedom to move along the x-axis, along the conveyor belt width with a servo-assisted linear guide. So we can control it everywhere with a millimeter resolution at the x-axis, but we have put it a low-budget pneumatic actuation system for the vertical transition of the recyclable. It is a low-cost pneumatic cylinder, and that is why we can characterize it as a low-budget system. Low-budget system is a must at the recycle industry if you want to make a system that is that can be massive applicable to everywhere that recyclables are produced, so everywhere in the world. The first three robot sorters are characterized by their huge recovery capacity that they can do, the big rate of recovering, but they have not so good success ratio. So, in order to improve the success ratio, we have made the 2.5 degrees of freedom robot, where we have basically bolted a 1.5 degrees of freedom robot on a platform that can move along the direction of the conveyor belt. So we can have exact the same velocity between the suction cup and the recyclable during picking. With this way, we can ensure that the success ratio is much bigger. And if we feed the recyclables with a constant ratio, we can manage to have the less residue at the residue that will be landfilled at the end of the system. With all those 5 robots, we managed to pick 120 picks per minute. That equals to 1.4 tons of recovered material per shift, per 7 hours. So in a 3-shift duty, we can recover up to 4 tons of materials. We can, at this time, we have 7 materials. We can classify the recyclables in 7 different classes. But as our libraries and our identification system gets better, this number grows. In order to make the system easily transported to the edge of Greece and to remote places, we had to find a way that the system does not need special equipment or heavy equipment in order to get unloaded and loaded to the truck. So the idea was to put 4 legs into the structure of the container. Those legs can be extracted from the structure, and the pneumatic cylinders in those legs can take care of lifting or unlifting the container. With this way, here you can see the container leaving the facilities at Crete, and we sent it at an exhibition at Athens. We're very happy to say that only after 1 hour from the unload from the truck, we can feed the PRMRF with recyclables and function. In order to monitor the performance and optimize our system, we have some metrics. We have some parameters that we try to optimize. It is the picks per minute. As I told you before, we have 120 recovered items per minute from the robots and another 20 from the magnet. The pick success at this time is 94%. We had a lower success rate, and that was the reason that we made some changes to the system. And from 91 we went to 94. Basically, we had also another type of robot, a 3 degrees of freedom robot, but we changed it to be 2.5 as the ones I showed you, because we had a very good performance of the 2.5. The number of class recycled from the system, right now we have 7, but as I told you, this number grows. Of course, the purity of the recycled material is a parameter that is crucial, because this number shows also what you can do with the sorted material after you send it to the factories. We try to make it as much better in order to be able also to sell the recovered material to the food industry, because at the food industry you have to meet some standards. And also a very crucial thing that we have to do is to make the operation convenient for municipalities of remote islands to function. So we're not going to find experts at the remote places. So we had to automate many procedures, such as the maintenance of many sorters and the cleaning of many things. So we have managed to make the system be operated by one operator that needs some training in order to operate the PRMRF, and one worker that is basically responsible of loading the PRMRF and being sure that not huge things or dangerous things will enter the production line. Also, the operator is using an application that we have made in order to control the robotic sorter, in order to start and stop the system, and in order to performance the monitor and see if something is going going bad. For example, we have many sensors, vacuum sensors and optical sensors, in order to get the feedback if the recyclables were sorted, or maybe if we have something blocking our vacuum, or maybe a recyclable have clogged into the bin, so we can see if something is not going good. Also, the municipalities can have a real-time composition analysis of the recycle of the citizens, and they can apply fines to different regions if the quality is not as it should be. And we also have an HSI and RGB fusion and monitor system in order to examine the difficult cases. And when we have when the HSI system gives something different from the RGB, so when those two subsystems disagree, we can examine those cases and who was right, and retrain our models. Also, with collaboration with KUL, and in order to make the system better, KUL has made the digital twin of the system, where we can test different scenarios, different architectures, in order to optimize the performance. For example, given different compositions, every place has a different composition of their recyclables. So given the different composition, we can fit those parameters in the digital twin and change the bin allocation in order to meet the best scenario. We can change materials prioritization with different prices of materials. Those prices change in the stock market like every hour, so you can update and put those prices, so the system will try to optimize the euros picked per minute, so it can prefer to pick an aluminum over a PET, for example, if the aluminum price is too high. And also, we have tested the multi-gripper multi-robot. Basically, the Catholic University of Leuven has made novelty grippers, such as this one, that sucks the recyclable and ejects it straight at a bin. Well, at this video, it is back to the conveyor belt, but now we have put the shelf there. So we can, with the digital twin, we can analyze the performance and see what worked better and why, and then fit those parameters in the real system in order to optimize the system. KUL has also developed a target planner that analyzes in real time the location, the price, and which gripper is on which robot and what bin is where, in order to give the best choice, but in real time. And we have seen that we had a performance of up to 20% using this system. So we are now integrating this target planner to run in real time, and that is a bit challenging, but we believe that at the next update that we will do, we will also put this feature. Now we are at the stage of putting the system in full scale and trying to function it and stress test it as much as we want. We want to benchmark it and to find the best parameters in order to have the optimized performance, and in order to give those numbers to the municipalities and try to install the system where we can. This is the other partners of the project, and thank you very much for your time.
Thank you so much, Freddie. You have already shown us some promising numbers when it comes to performance. So I wonder what do you think the implications of this performance are for the future of AI-driven recycling, let's say?
What is the future of this technology?
Yes.
Well, I believe that it can provide a sustainable solution to address this difficult problem of the remote places. Generally, in Greece, there are many people waiting to see how this system will function, and they want this system to their region. And also, I believe that it is a very good example of each country has its problems, and providing a solution that can be also applied, for example, to other countries out of Europe that have the same problem, but are not at this scale, in order to make a solution.
Exactly. All right. Well, thank you, all of you, for presenting the work that you're doing and how these AI systems are supporting the objectives of the Green Deal. I don't see any question in the chat, so I suggest we wrap up here. If anyone wants to be in touch with you, I'm sure they can reach out via the project websites. Same, you can also reach out to our AI on Demand team if you want to add any assets, any data on the platform, or are interested more generally in the platform. Feel free to reach out. So I would like to end with a big thank you to the speakers for your valuable contributions, and of course a big thank you to the audience. I hope that you found the discussion here valuable and inspiring. And if you enjoyed the session, I encourage you to visit the AI on Demand's website to see what are the assets existing there, including some of the projects presented today. And you can also join the community of researchers existing there to share your own resources. Feel free to stay updated by following us on social media as well, on LinkedIn, X, and YouTube. So thank you once again, and I look forward to seeing you at our next session. Have a nice afternoon.